Hi class, let's talk about how to sort an array and selection sort algorithm. So sorting is just basically arranging things in a certain order. It doesn't have to be numbers. For example, we can sort things in alphabetical orders. But in this demo or trying to explain this selection sort, we are going to assume that we are just sorting numbers from the smallest to the largest, which we call ascending order. The array that we are going to sort is num. That's the name of the array that we are going to do. So in terms of sorting algorithms, actually there's a lot of them because it's very important in many applications. Later on in your software engineer career, if you're interested, you would have to take algorithm classes, and sorting is one of the first ones that will come up. Basically, it's like a set of instructions, how to do certain things, to make sure that things are accomplished as expected, right? We are going to talk about two kinds of sorting algorithms. The first one is selection sort in this video. The next one we'll talk about bubble sort. So what is selection sort? Basically, you're given a array of number from 0 to the last index of the array. And then you would find out what is the smallest number in the whole array, and then swap that number to the first number, which is num0. You swap it, and so num0 has the smallest number in this array. Now it's kind of like you partition it, so the num0 has the smallest number, and then you have this array of numbers that's not sorted yet. And so then you find the smallest number in this unsorted array, find the smallest among it, and then let's say you find it over here, and then you swap it with num1. And so you basically continue doing it until you got to the end of the array. So in display 7.11 in your book, depends on which version you use, this is how it works as an example. So you go and find the smallest number 2 is in position number 3, and then you swap with position number 0, and so you swap it, and so now A0 has a value of 2 and A3 has a value of 8. Now you know this is the smallest number, so you won't touch it, right? And so you find in this this array which is the smallest, so the next one that is smallest is 4. So you swap 4 with the next available, like you're basically trying to build this side up, and so you swap 4 with 6, and so it become 2 4, and then basically the colored side of the array is sorted, and the one with the background that is white is unsorted. So I will make another observations also. We are basically building the order list from the smallest number one at a time, because there are other algorithms that actually doesn't in a way do it one at a time. The left side of the array, which is the smaller index, will be growing, right? And the right hand side, because it's sorted, and then the right hand side, which is unsorted, is shrinking. So before I write a program like this, I usually will think about how to build a mechanism of using machine kind of pseudocode, the book would say, to see how to write this program. So I would actually invent a integer called partition index, which is 0, which indicates where the unsorted side of the unsorted array will start. So it will always start from 0 to the last one, right? And then find a minimum from this partition index, the array at this position to the last one and find the minimum, and then swap it with the partition index, because that's where the first unsorted is. And then once you find the first one, you can increment the partition index by 1. And then now the partition index is 1, and so you find from num1 to num last index what's the minimum, and then swap that with the num1, right, where the partition index indicating. And so you continue until all the number are in order. We are going to do a demo. I've wrote part of the program basically, and I put all the comments inside. I think it's very important because I can check my own logic when I write it down, and understand what I'm trying to create here. So you can see that this is the description of the program, and then I think there are two functions that we can use. It would be helpful, so it's kind of like a helper, right? So we would give the function the array. Actually, I can actually use it as let me see. Yeah, I can actually make it a const because I'm not going to change the value of this. So I would pass in an array. I would give it a start index, a last index, so I know within what boundary of that array I'm going to search. And the what I want the function to do is to return to me the index of the smallest number within this section of the array, and then I would do the rest later. So you can see that this is my purpose. Assumption is that the last index is smaller, is larger than or equal to start. Let's put it that way. I'm very careful. Like I would say that, try to make sure everything is working correctly before you try to improve the performance, because sometimes the boundary conditions is what will throw us off. But try to make sure that it works well without creating error first, and then we can then later on improve it. So let's see how to another function that we are going to implement is swap, like we said in our mechanism. So after we found the minimum of within a section of the array, we are going to swap the number, right? So that's the two step that we need to do. The rest seems to be okay. We don't need a function for it. And so the swap, you've seen it before. Remember that we have to do the ampersand so that the value that's passed inside can be really swapped, instead of just doing it inside the function and nothing actually happened once the function is done. So I'm just using the swap that we used before, and let's try to implement how to figure out the index of the minimum. So let's first think about so we'll start with the start index, or actually we have an assumption that the index makes sense. The last one is larger, but I think we would just make sure that's the case. So we would do an insert statement, which we didn't talk about. But basically what the insert statement does is to make sure that a condition is fulfilled. So I want to make sure that the start index is always smaller than or larger or smaller than or equal to last index. So we'll just put in there, if things go well, nothing happens. But if this condition doesn't is not valid, then there will be a complaint when you while you compile this program. So next thing, we want to do a for loop, obviously, to try to compare all the find which are the minimum number. So let's say the minimum number is the first one. And so it means that the index of the minimum number is start index for now, right? And then we go into a for loop. The for loop, actually, let's say is not 0, but the next one that we will touch is probably +1. And then this is smaller than and equal to the last index. And we are going from the start to the end, and the number is going from smaller than larger, right? So what we'll do is we will compare the minimum to the next one, next element, basically. So so what will happen if minimum is actually larger? It means that we found the next smaller number. So what we'll do is now min has to equal to this new number, and then the index of min will then equals to I, right? So if the other cases, we don't have to do anything, so we just continue to loop, and then once we got to the end, then we will return the value of index min. So let's test this. Like as usual, we always test the function to make sure it works before we go on to making like a huge program, and then debug is actually much harder. So since we have some arrays already there so I've put this in there, they are my test cases. So let's try to test if this function work. So let's call this function, which is index of min, and then the array is score. The start index, let's do 0, and then the last index is array size -1, right? It will return the smallest number. So let's see out that number. We can also say actually, how about let's see what is the value that it found is the smallest number. So we return the index, and then we would just basically put it to within the square brackets, so that it get us the value of that particular number. So remember, nothing, we are not swapping or doing anything to the value in the score array. So let's see. This is 7.3 demo CPP, and then let's see what happens. So it actually output the sorted array at the end, but then it also give us, the smallest number is -12 in this whole number, in this array of numbers, which is correct. So let's test it again with another array, and then maybe let's not output this, which is So let's run it again. We have to compile though. So in here it find that it's -4, which is correct also. Let me test with but you know, you see all the -4 is at the end, so let's test this one. And it's -1 is what it found. So it looks like our function is working. And now let's do the part where we would, you know, put everything together. We could have put it in a function, but I think right now it's fine. I'm just going to try to implement it in the body of main. So we would have a partition index equals to 1, like we have planned for that. And then so from min the partition index to the last index, which we will use a for loop, we will swap the number. So basically we have to swap the whole array. Basically, if the array is of a size 5, we have to do it 5 times, or in a way you can do it 4 times, but that's for performance purpose. So let's make sure that things work first. Actually we have to say that it starts with that's, you know, number 2, right? Find the mean from partition index to the last index. So that's why I equals to partition index. I would be smaller than the array size, which is yeah, that's the last index, and then I plus plus, it will increment. And then what are we going to do here? So we are going to swap the we are going to swap, let me see. Actually so this is actually, would it be easier to think that this is 0 or partition index? Anyways, let's do a swap first. So we would swap from score of partition index. I think this is what I want to do is like this. So because I want to make sure we understand this is the partition index, which is getting updated, even though it basically do exactly the same thing, but I think conceptually it makes it clearer for programmer myself to understand what I'm trying to accomplish. So I'm trying to swap the number partition index and the index of the minimum, and the index of the minimum, we will do it like what we did earlier, and then call the function. So the start index is actually the partition index, and then the end of the index is the array size -1. All right, so and then to test it, we have to figure out, you know, print it out so that we can see it, and then we will comment out what we did before. Sorry. So we'll compile it. So that's an error because we forgot have the semicolon. So don't do that. Always try to do semicolon first. That's usually my habit, but this time didn't happen. So 6 numbers, which is right, and then but you know, we already sorted it to start with actually in this, so it's okay because we need different kinds of test cases. So that's one of the test cases that I used. Let's compile again. Run the program. Let's see. So 1 2 3 4 5 6 and -4 3 10 16 41 42 looks right. why I have so many test cases here is also because I realized, when I received your lab assignments, I think a lot of people didn't exactly do a lot of testing, and so you might cover some cases but not all the other cases. So always think about, how to break your own code. To be a good programmer, actually you need to know what's the best way to, or to break your code so that you make sure that your code is invincible. That's what we want. Anyways, I think this is the end of the demo. To review some of the things to consider, using the assert with the condition might help you to catch some unexpected problems or bugs, or at least make sure that your program doesn't work in an unexpected way. Second is be careful of the boundary cases, because this is usually, I will tell you, in your homework, I can guarantee you will get into cases where the boundary case is where you didn't catch it. For example, you lost one number, or you didn't count one less, or so on. Trade-off. Actually, I can make this code more efficient. I can actually not compare. For example, in the last one, you don't have to swap. The last one will be the last one, but we didn't do that kind of optimization per se. So it sometimes is a trade-off of, is it easy to understand the code, or I'm showing you, and so I don't want to make it too complicated at this point. And so we usually go with the accuracy first to make sure that the code is working like what it's supposed to be, and then we go in and change for optimization or performance purpose to make it function better. Next one, bubble sort. I would see you soon.